we work on cosine reduction formula. So we want to calculate integral of cosine x raised to the n power. What we do is we peel off cosine squared x, and we have a remaining power n minus 1. The reason for peeling off cosine squared is, if we recall the main trig identity, cosine squared equals to 1 minus sine squared. 1 minus sine squared x times cosine to n minus 2x dx. Then we're going to split that integral into two. Integral of cosine now raised to n minus 2 power minus integral of sine squared x cosine to n minus 2x dx. And now we're going to concentrate on the second integral. And the way we're going to address is we're going to write sine squared as sine x times sine x. So let me rewrite the second integral and get cosine squared as cosine times sine, and copy the first integral. Now we're working with the second integral, and for the second integral we want to do integration by parts. So if you recall that for integration by parts we need to define what is u and what is v prime. U is going to be sine x. V prime is going to be the remaining piece, sine x together with cosine raised to n minus 2 power. To differentiate sine x is straightforward. I get u prime equals to cosine x. Integrate sine x cosine raised to n minus 2x dx. It's a little bit harder, so I'm doing it somewhere on the side. So I'll do kind of w substitution, so w equals cosine x, then dw equals to negative sine x dx, so dx equals dw over negative sine x. So if I do that substitution, so I'm going to get integral sine x w raised to n minus 2, because w is cosine x, and dx is dw over negative sine x. Sine cancels out, so we have integral of w raised to n minus 2 dw with minus. So final answer is going to be minus w raised to n minus 1 over n minus 1 plus c. Do back substitution that w equals to cosine x. Recall that's the expression we're going to put here. So if I do that expression with w written as cosine x, so I'm going to get cosine x raised to n minus the first power over n minus 1 with minus. Okay? So that part was our auxiliary calculations to go from v prime to get what v is. So that is now our v. So we are ready to write down the integration by parts for that second integral. So I erase the auxiliary calculations. Alright. So copy the first integral. Minus. Write an integration by parts for this one. So we have uv sine x negative cosine to n minus 1x over n minus 1 minus v u prime integral of negative cosine to n minus 1x over n minus 1 times cosine x v u prime dx. Okay. So I'll do a little bit of algebra here. Distribute minus, distribute over minus, 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 minus. So copy the first integral. So integral cosine to n minus 2x dx. Distribute minus, minus, minus give us plus. Plus sine x cosine raised to n minus 1 x over n minus 1 minus 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 3 minuses give us minus n minus 1 is a constant, so I'm going to pull it up in front in the denominator. Integral of cosine n minus first power, and first power give us total power n dx. That's an expression which we wanted to get. Now we recall that this expression is equal to our original cosine to n integral. Now I'll erase some stuff and we'll return back. So that's where we are now. So what you notice is we are looking for a cosine raised to nth power of x dx, and we have it on both sides. So we have it here, and we also have it here. So what I'll do, we're going to solve for it. So I'm going to add 1 over n minus 1 integral of cosine raised to n power x dx to both sides. I'm going to add it to both sides. So on the left side it disappears, and the right side becomes, so integral cosine n x dx plus 1 over n minus 1 integral cosine n x dx. Left side, copy these guys. I'm going to get integral cosine raised to n minus 2x dx plus sine x cosine raised to n minus first power over n minus 1. So just copy the left side. On the right side now I'm going to combine coefficients of integral. So I have 1 plus 1 over n minus 1 integral of cosine n to n dx. Calculate the coefficient of this guy, 1 plus n minus 1, so we can write 1 as n minus 1 over n minus 1. So we're going to get a total 1 is n minus 1 is common denominator, n minus 1 plus 1 is n. Integral cosine of x raised to n power. Copy the left side twice. I will abuse notation. I'll copy it once. Cosine n minus 2x dx plus sine x cosine n minus 1 x over n minus 1. Now I want to get rid of coefficient of integral on the right side, so I'm going to multiply by its reciprocal of a coefficient. So n minus 1 over n, multiplying both sides by integral cosine n minus 2x dx plus sine x cosine to n minus 1x over n minus 1 equals to integral of cosine to nx dx. Distribute that coefficient, and if we distribute it, we're going to get n minus 1 over n integral cosine raised to n minus 2x dx plus n minus 1 and n minus 1 cancels out here, so we have sine x cosine raised to n minus 1x over n, because n minus 1 and n cancels out, equals to integral of cosine x dx. And that is where formula we are looking for. That is cosine reduction formula. I will rewrite it one more time, a little bit more in the standard way. So I'll start with saying integral of cosine raised to n power x dx equals I'll write this expression firstly. So I'll write sine x cosine raised to n minus 1x over n plus n minus 1 over n integral of cosine n minus 2x dx. That's the formula we are looking for. That's cosine reduction formula. So what it does, it allows us to reduce the power of cosine. So we started with integral of cosine raised to nth power, and if we apply this formula, at the end we need to calculate cosine raised to the power which is 2 less than the original one.